So to example 5. A flywheel has a mass of 100 kilograms and a radius of gyration of 150 millimeters. It is accelerated from 100 revs per minute to 250 revs per minute at a constant rate in 15 seconds. What is the power absorbed by the flywheel in this time? The first thing we have to do is look what information is given to us. So we're told that the flywheel has a mass of 100 kilograms and a radius of gyration of 150 millimeters. Well, the radius of gyration is the square root of the moment of inertia over the mass, and just rearranging that, we have the moment of inertia is equal to mk squared. So that's 100 kgs by 0.15 meters squared, and that works out to be 2.25. We're told that the flywheel is accelerated from 100 rpm to 250 rpm, so we need to convert revs per minute to radians per second. So omega is the revs per minute divided by 60 multiplied by 2 pi. So 100 revs per minute becomes 10.47 radians per second, and 250 revs per minute becomes 26.17 radians per second. So we can put this information back in here and change the question. So we can say that a flywheel has a moment of inertia of 2.25 kilogram meter squared. It is accelerated from 10.47 radians per second to 26.17 radians per second at a constant rate in 15 seconds. What is the power absorbed by the flywheel in this time? So kinetic energy is half omega squared I. So the change in kinetic energy is half, I is going to be constant between the two of them, omega 2 squared minus omega 1 squared. I know omega 2 is 26.17 and omega 1 is 10.47. So the change in kinetic energy is equal to 647.15 joules. Now, power is energy over time, or the rate of doing work, and work is measured in joules. So the power in this equation will be the kinetic energy in joules divided by time, which is 15 seconds. So it's going to be 647.15 joules divided by 15 seconds, and that's 43.2 watts. So that is the power that is absorbed by the flywheel in this time.